Hello and welcome to Partially Redacted, a podcast where we discuss privacy and security engineering and related topics. I'm your host, Sean Faulkner, and today I'm joined by Daniel Situnayake, head of machine learning at Edge Impulse, and we'll be talking about the privacy and security challenges with machine learning and gathering data from IoT edge devices. Dan, welcome to the show.
Hey, Sean, great to see you. How's it going?
Great, yes. It's always great to see you. Thanks for being here. So we worked together in the past at Google, where you at first were, you're on the Dialogflow team, which is Google's natural language processing tool, for those that aren't aware. And then you went to the TensorFlow team, and today you're head of machine learning at Edge Impulse. And I think you have a really interesting career path to what you're doing today. So can you start off by giving a little bit of background about, where you started your career and how you ended up where you are today?
Yeah, absolutely. So I've done a lot of random things throughout my career, to say the least, including, insect farming and software engineering and teaching. But there's kind of the narrative that connects it all together, I guess, is like trying to make use of different types of data from the perspective of a computer, like figuring out ways to understand what's going on in the real world using a computer so you can then make decisions based on that information. So I started out doing some cool stuff with sensors and biometrics and auto ID technologies, things like barcoding, RFID, and that's sort of one way of trying to track what's going on in the real world with computers. And then I spent a bunch of time working in various companies in Silicon Valley, doing things around location-based services, GPS. Then I ended up working in stuff to do with conversational interfaces. So this is sort of understanding what people mean and what people are trying to say. And through a sort of big adventure in the world of agricultural technology and agricultural automation, I ended up starting to play with sensors and understanding what's going on in complex environments where you're having to keep track of maybe temperature, humidity, noise, vibration in an agricultural setting. And that sort of led me down this path of like trying to understand what are the ways that you can interpret that sort of data, especially the stranger data that isn't so obvious, things that come in time series at a high frequency. I think all that stuff's really fascinating. And at Edge Impulse, what I do right now is basically help build developer tools that allow embedded engineers to build systems that use machine learning to understand data from the real world. So machine learning has some real huge advantages when it comes to figuring out how to make sense of this kind of messy data. And the issue is that the tool chain around machine learning is really, really difficult, really, really complicated. So we are building tools that empower embedded developers to work with machine learning without having to take a year off and go and study machine learning.
Yeah, it's great. I think there's been a long history of, from a tool chain perspective, like a lot of the things around machine learning, because a lot of it came out of, academics, and they were not built for essentially a consumer or an application engineer, or in your case, an embedded engineer to be able to use those things. They were for essentially researchers that needed to accomplish something to prove a theorem or prove something that they were going to later publish. So the UI and usability was certainly an afterthought at best.
Exactly. Yeah. This is all about how does machine learning make the leap from the lab into the real world, and how does it go from being a technology that's only proven on these toy data sets and benchmarks and things that academics are sort of poring over as a community. How does it make it the leap from that to working with real data from real businesses or real people that are out there in the world experiencing all of the chaos and noise that comes with it?
Yeah, and your particular area of expertise or what you're focusing on at Edge Impulse. And I believe that, with your work on at TensorFlow Lite as well, was in sort of the IoT edge device space. So how do you apply machine learning to these types of devices? So, I think that's a great place to kind of start things off. For those that are maybe not familiar with this technology space, let's just start with the basics. What is an edge device?
Yeah, really good question. So it's kind of an amorphous term in some ways, but if you think about, we're all familiar with this sort of network diagram of nodes connected to each other, some of which are computers, some might be servers, some are clients that are doing something or other. And in a network diagram, you typically have some stuff that's towards the middle of the network that has lots of stuff connected to it, and some stuff that's at the edge of the network that only has a few, incoming connections. And in practice, those end up being the computers that are sitting out there in the real world, interfacing with reality and maybe collecting data and sending it back through the network. So these are the edge nodes, and that's where that term comes from. They're these things that are sitting at the edge of the network. And what they actually are varies, right? So your mobile phone is an edge node, your laptop is an edge node, but also there are things like little IoT sensors and devices that are sitting maybe, scattered throughout a big farm, or monitoring equipment in a factory and capturing data and reporting it back. Beyond that, though, there are other things that are a little bit more confusing. So there are things like edge servers, where you actually have quite a big, beefy machine that's computationally quite powerful, that's sitting in a factory and helping crunch data that's being generated by a lot of sensors or cameras or that type of thing. So it doesn't necessarily always mean tiny resource constrained devices, but what it does mean is devices that happen to be sitting at the edge of the network. And there are certain properties of the edge of the network that they share, and that create kind of an interesting environment for performing computation. And privacy is one of those things that is interesting around the edge of the network.
Yeah, and that's certainly the topic that we're going to be diving into. But I guess what can you, before we get there, can you give a couple of examples of use cases that people are using AI or machine learning on edge devices, maybe through the Edge Impulse platform today, to solve actual real life problems?
Yeah, absolutely. So, one of the kind of most common applications that I definitely have to touch on is with voice assistants. And one reason I have to touch on that is we've both worked adjacent to that at Google, Sean. Yeah. But another reason is that this is the largest deployment of edge AI, edge machine learning that exists right now, because most mobile phones at this point have some kind of always-on chip which is running a model which is looking out for a wake word, whether it's the Google one or the Amazon one or the Apple one. I won't say them out loud because I don't want to set off all of my devices. So the idea that if you want to listen out for someone saying a wake word on a device is pretty cool, but we don't want to achieve that by sending a stream of data constantly to the cloud for a big model to pick over it. Because first of all, it's going to be extremely expensive and run your battery down and use all your data and all of that stuff. So from a practical standpoint, it wouldn't really work. Your phone would be red hot and running out of battery within an hour. But also extremely important, we don't want to be sending a stream of audio from our phone at all times off into the cloud. Obviously, huge implications there from a privacy point of view. You don't want to have this sort of always-on monitoring that's then streaming data off-site and under who knows what kind of security conditions. So that's one of the most kind of widespread examples of edge AI at the moment, is that you have a little model running on the phone on a chip that's sort of secure and isolated and isn't sending data up to the cloud and is able to recognize when somebody's activated the device. So that's just kind of one example, but there are use cases across every possible thing you can imagine. There's tons of user interface type applications like that. There are also loads in industry. So for example, maybe you're monitoring a piece of machinery and you want to understand whether it's working effectively or whether it's looking like it might break down soon, looking like there might be some problems. You can attach a device to it that maybe captures audio or vibrations or some other signal, maybe current analysis from the current that's flowing through the machine's components, and you can train a model to predict when a machine is likely to fail, and so that can give you some early warning of whether you're going to need to replace a part, and you can plan better and avoid shutting down your factory unexpectedly. And the kind of cool thing that's become possible pretty recently with edge machine learning is that we can actually do really, really advanced computer vision on the edge. So one thing that is a super cool demonstration of this is that there are now researchers and conservationists who have got devices out there in the field, like imagine in the middle of the jungle, that are sitting there and they want to take pictures of interesting animals that come past, and they don't want to just take a picture when a bit of leaf moves around or a tree branch sways in the wind. So they can't just use a passive infrared sensor that would get lots of false positives when a tree branch moves, but instead they can deploy a machine learning model that's trained to do some computer vision tasks. So for example, recognizing particular species of animal that are of interest and making sure that when that kind of animal walks past, the photo gets captured and saved. And if it's just a tree blowing in the wind, then it can delete the photo. And that means that you can leave the device out in the field much longer before the memory card fills up, and the researchers don't have to go out into the middle of the jungle, quite so often, and they're able to collect much more interesting information about what's going on.
Yeah, it's amazing. The beyond the memory limitations as well, there's also just you're saving people a ton of time to have to go through and sift through all those random leaf movement pictures. And also, I just wanted to flag that I'm sure besides you not setting off your devices, I'm sure the audience appreciated you not saying the A, G, or S word earlier in terms of setting off their home devices for those that are listening to this. But so, you mentioned the idea of using sensors within, observing animals in the wild or potentially within a factory. So there you have sort of these probably like fairly limited from a resource capacity devices that are deployed in these different locations. And they're collecting data dynamically and in real time without round trips essentially to a central system. But the devices are also physically available for someone to tamper with if they got a hold of it. So I imagine that leads to some unique challenges in terms of security on the device or, how do you prevent sort of tampering? Can you talk a little bit about what things might be in place from a technology perspective to prevent essentially tampering or even if someone got a hold of it, essentially prevent them being able to maybe read the data that's on it?
Yeah, so I mean, with devices that are on site, either in your location at a factory or even out in the field somewhere where you have no control over it whatsoever, there's potential for people to interfere with and tamper with devices. So this is something you definitely have to think about when you're designing your application. And it kind of goes beyond the machine learning part, but just how do you design software and hardware that's got to run in an environment that has that type of potential threat. One of the benefits of using machine learning on devices is that you don't necessarily need to store raw data. There are ways that you can use machine learning on a device to interpret what's going on and store the results of that interpretation, but not actually store the raw data. So a good example of that is if I want to know how many times a particular bird has sung, if I'm trying to keep track of local wildlife. One way of doing that would be to record audio and continually capture audio and then come along every so often and grab the captured audio and listen to it and see how many times the bird was singing. But obviously, if I have devices out there recording audio in the field, they'll be picking up all sorts of other stuff as well as the bird. And that might not be acceptable if you're setting up these devices in places where people live. So one thing that's really cool is that if you deploy a model to the device that can recognize when this particular bird is singing, you, first of all, don't need to capture the audio, don't need to store the audio anymore. You can capture it, run the model, and just keep track of how often it detects the bird singing. And another cool thing is that it saves you the time and effort of having to go through that audio yourself and understand what's going on.
Yeah, I imagine from, even beyond just like security, like talking about privacy, where you have these devices that are maybe, observing things out, in the wild, people could be come into frame essentially. But if you're not actually storing the data on the device, you're essentially just doing inference on the device, then you have a computed result, but you don't necessarily have the raw data. So, and if essentially the inference engine has nothing to do with people, then you're not actually it's basically all ephemeral. There's no sort of long-term history of the data or what people were doing with regards to what's stored on the device.
Yeah, absolutely. And so, like, one of the key components of any AI project is thinking about ethics and thinking about, does this application have a potential to produce harm? And, that could be completely unintentional harm. And this isn't something you just have to think about for AI projects, by the way. This is something you have to think about when deploying any technology into the real world. And we just often don't think about it that much. But it's really important to. And one of the things that edge machine learning can help with is reducing the potential impact on people's privacy because of capturing raw data. There are examples like having research projects where they're trying to monitor wildlife in a local setting that the local people aren't necessarily going to want to be, captured by. They don't want to be featured in the photographs that are being taken by researchers. So if you can filter out pictures of people, or if you can only capture pictures of animals, then maybe that helps make your project work better with the people who are going to have to live around it.
Mm-hmm. And in the situation where you're using edge devices to essentially collect data, maybe like real-time information that then is sent to like a central server for, informing the model and, essentially updating the model and developing a better model, like what's the typical controls around preventing essentially that sensitive data getting leaked during some sort of round trip to the server?
Yeah, so it's very tricky, right? So you've got so many different points of failure where something can go wrong, especially when you don't have access to the hardware, more like when other people potentially have access to the hardware who are not part of your team. So from a very fundamental basic level, the hardware itself can be compromised. There are ways that you can tamper with hardware and extract signals from sensors that are on the device, or maybe do something at a software level which gives you access to data that you shouldn't have access to. So the device can be physically compromised. You're also relying on network security. So does the device have a secure connection back to the place that's where you're doing the central data processing? So like, especially if you're on a remote site or in some kind of place where you don't control everything, there's no guarantee that there isn't some kind of man-in-the-middle attack going on, or you can't necessarily even trust internet service providers or network providers. It's not always safe to assume that these are just sort of passive entities forwarding your data. And then even in your own infrastructure, you obviously in a modern business don't just trust all of your employees to have access to all of your data, and you need pretty complex and sophisticated and sometimes expensive tooling and technology to allow you to manage this data which you're collecting. So often it's far better if you can avoid collecting it in the first place. If you don't need to have tons of raw data from the field around, you shouldn't, because then you avoid the entire liability of having that and needing to protect it.
Yeah, is one of, I guess, the values of deploying essentially ML models directly to these edge devices is that the fact that you can do inference directly on the device. So that way, the data that you're actually collecting doesn't go anywhere.
Yeah, exactly. So rather than sending data off to some remote cloud server where it then gets processed, you're doing the processing on the device. And there is some huge benefits to that, completely leaving the kind of privacy and security stuff to one side. First of all, you can have really low latency. So if you're not waiting for a round trip to the internet, then you can potentially respond much quicker when the user says the wake word or when the animal walks by and needs to get photographed. Secondly, reliability can be much better, because if you're not depending on a network connection, that takes out one piece of complexity that might kind of shoot you in the foot if your internet connection goes down, like mine did a moment ago. So these are really key things. And if you think about some edge applications, it really isn't possible to do a good job without these benefits. So the prime one there, if you think about self-driving cars, that's almost the ultimate edge device, right? Because it's a thing out there in the streets. It doesn't necessarily have any connection to the internet at all, and it's got to make all these complex decisions interacting with a really complex environment. And it really wouldn't make sense to have a self-driving car that depends on the internet for everything it does, because what's it going to do when the internet goes out? Is it just going to run people over or suddenly slam the brakes on in the middle of the freeway? So that sort of takes this to an extreme, but for most applications, there's some element of like benefit to being able to do the processing locally. And the real constraint is around the hardware, what the hardware is capable of, what type of models can fit, and how much energy do you have to perform computation.
Yeah, and imagine, taking, I guess, the self-driving car example even more extreme is like if you think of like space travel and having devices there that are, maybe monitoring oxygen levels on the space device or something like that, then, well, you don't want to do a multi-minute round trip back to a server on Earth in order to do some sort of inference versus being able to do it right there in real time.
Exactly. Yeah, these are the ultimate edge devices, literally going out to the edge of the known universe. The Voyager space probes, there's got to be a certain degree of autonomy in managing your systems if you are going to be surviving a huge amount of distance from human communication. So that just kind of shows what you can do if you can basically take a bit of what would previously require central control and push it out to the edge. And what we can do now with the types of algorithms that we've developed and the types of silicon that we've developed over the last decades is absolutely mind-blowing. And we're able to really take quite complex models, things that weren't even possible 5 or 10 years ago, and put them on tiny, tiny devices that don't use much energy.
Pardon the interruption, but it's me, Sean, the host, talking to you directly. I hope you're enjoying the episode, and if so, please subscribe and leave a positive rating and review. You can also join the Partially Redacted community at skyflow.com/community to make show suggestions, interact with me, other listeners, and privacy experts and enthusiasts. All right, now back to the show. So going away from sort of the value of essentially doing inference directly on the device, and of course the value there in terms of, reducing round trips to be able to do like really interesting, cool things like, keeping an astronaut alive on the International Space Station, for example. What about in terms of training? So, in one of my recent interviews, I talked to Dr. Yoon Liu from University of Victoria, and she talked about a bit about the privacy advantage of federated learning, where training is essentially happening locally and then the resulting model shared back to some sort of central system rather than the raw inputs. Is that something that's going on in the sort of IoT edge device ML space?
So it's very early days. I think federated learning is one of those things that there's a lot of excitement around. It has a huge amount of potential, and it is being used for some real things. The canonical example is with mobile phones, where you're typing in words on your little horrible keyboard and you make a mistake and then you correct it. The corrections you make are sort of pooled, and models are trained to make better predictions in the future, and the results of training those models are pooled together across all the devices in a way that still maintains privacy between different users. And so that's really exciting. However, there is a big challenge using this type of approach, especially when we're talking about IoT, because training typically it requires some understanding of what the data represents. In most cases, not all, but in most cases, what we're trying to do is train a model that sort of takes a given input and understand what it means and gives you an output that or lets you take some action as a result. And so that implies that a lot of the time we need some kind of label that tells us what a situation means. So for example, when we're out in the field, we've got our camera set up in the jungle and a tiger walks past, we want to know that was a tiger versus that was a squirrel. And the problem with these approaches that let you do some of the training on the edge and share the results of that, the problem is that it doesn't help with that issue of needing labels, because there's not a person out there on the edge pointing out whether it's a tiger or a squirrel or a tree moving in the wind. So we find for a lot of applications, there isn't necessarily a good way to get those labels at the edge. And so that makes some of these really promising approaches a little bit out of context. That said, we're in very early days of figuring out how we can use these types of approaches, and I have no doubt that we're going to make progress in doing interesting things using unsupervised learning, where you don't necessarily need labels, but still on edge devices. And then there are these applications like the one with the keyboard, where people are saying, oh, that wasn't the word I meant to type. I actually meant to type something else. So you're getting the label in that case. So for those types of interactions where there is potentially a human involved who can provide that information, or for applications where there's some contextual information that might provide labels that's available from other sensors, it can be beneficial. But it's still very early days with this. I'm excited to see where it goes, but unfortunately, the data and the labeling is always the biggest problem. It's always the trickiest thing.
Mm-hmm. So when it does come to, the data and the labeling, so you obviously need a training set to train these models somewhere centrally, and then the inference sure can happen directly on the edge devices. But when it comes to sort of the ethics or the privacy concerns about the process of labeling and then actually generating the training sets, what are the types of things that are done to make sure that, essentially you couldn't identify some information about an individual person for whoever's sort of responsible for that process when it comes to machine learning?
Yeah, this is a really good topic. So just because you're doing inference on the edge doesn't somehow absolve you of thinking about privacy and responsible AI and ethics. In fact, it can amplify some of the things which are challenging in those domains. And what you've got to remember, like I was saying, is that when you're training a model, you often, a lot of the time, need some kind of label. You need some kind of human expertise that's being applied to a data set that allows the data set to mean something that you can train a model with. And collecting that data and labeling that data is a lot of the time going to involve a lot of the drawbacks that may be causing us to think about AI on the edge in the first place. Like, in order to train a model to recognize people saying certain keywords, maybe we need to collect a big data set of people saying all sorts of things. So how are we going to do that? And how do we do that in a responsible way and in a way that is in line with the privacy expectations of the people who are potentially contributing to that data set? And the key thing to remember is that, like, just because you can capture data doesn't mean it's okay. And the idea that you can sort of provide a service and soak up data from people and then use it to train a model isn't always something that's acceptable to do. And sometimes you might end up having to spend quite a lot of money to go out and collect a data set. And in a lot of cases, that's the kind of thing that makes a project succeed or fail. Whether you have the budget to do that effectively, whether you can genuinely go out there and create the data set that is needed for a project, rather than depending on some, data set that's public, that's lying around, or that you're somehow going to scrape data without people knowing. When we talk to people out there in industry who want to use this type of technology, one of the big considerations they have is always around, like, do we have to give up our data? Do we have to share our data with other entities? And you see companies that are coming through saying, like, hey, we've created this system that helps you, I don't know, optimize the efficiency of your machinery in your factory. All you have to do is share data with us, and then we'll share this system with you. And people don't necessarily want to do this, right? If you've got a set of trade secrets that you want to protect, or you don't want to give your competition a leg up, then maybe you need to be careful with who you share data with. And so potentially, like, some projects can be a non-starter if you're not able to access data in a way that fits with what your customers are wanting.
Yeah, I imagine, like, the value of or the sort of end result of a model largely depends on sort of the quality of the data input. So I imagine this is a huge sticking point for many, ambitious projects where if they don't have the means to essentially pay people in some capacity to collect that data, then the project doesn't essentially happen because they can't reliably get the data that they need to essentially train the model to create whatever sort of experience that they want to create. And imagine, I can, as someone who's used to be at Google, and I'm sure you can relate to this as well. Like, I can imagine having some sort of voice activated device in certain meeting rooms and stuff like that is probably something that a lot of people wouldn't be comfortable with, even if whoever sort of owns that device isn't necessarily letting people know that, or isn't necessarily doing anything bad, but it just can make people kind of uncomfortable with that because of essentially those things around trade secrets and so on.
Yeah, exactly. And I think the key thing here is that, like, in machine learning and AI, the algorithms get a lot of attention. Everyone's always talking about the algorithm that, I don't know, picks your song to listen to or what TV show you're going to watch next. Algorithms are interesting, but they're not the important part. And the algorithms that are used for most things in production around the world really aren't that cutting edge. They're fairly straightforward, well understood, simple things. And the value all comes from the data set. You're not going to take some magical whiz-bang algorithm and apply it to a problem and be able to do amazing things if you don't have a good data set. And the way I can prove that to you is, how do you even know if the algorithm is working well unless you have a good data set? I could sell you this magic box with a magic algorithm inside that supposedly solves your problem perfectly, but how are you going to even quantify its performance and evaluate it if you haven't collected a big enough data set to have a real representation of what's going on in the real world? You just can't. So that just shows, like, how important data is and how this whole puzzle, all of the different parts of it, kind of only fit together if you have data.
Given how important this is, and how much it could be a limiting factor for essentially like a business being successful, which at the end of the day prevents that business from probably making money. Are there active projects or companies that are looking to actually kind of try to solve this problem from like an ethical and privacy standpoint, to be able to create these types of data sets that people can actually use to train these models for these maybe more sophisticated, maybe sensitive type of situations?
Yeah, so there's loads of cool stuff. So one of the interesting things is there are a bunch of organizations out there that are trying to collect big data sets that have been collected from people who have given permission and where the data is licensed in a way which allows it to be used freely by anyone. A really good example of that is Mozilla's Common Voice project, which is collecting a lot of speech data along with annotations that tell you what the speech means. And that's free for people to use to train models that are understanding speech. There are also loads of efforts going on to reduce the data requirements for projects. So there are things that happen on the algorithm side where people are able to develop algorithms that work with small amounts of data. And then there are interesting things happening around synthetic data. So can you potentially generate data that is representative of the real world but didn't come from actual samples of the real world? It's been created as a simulation of reality, but you can still use it to train models. So all of these have different challenges and implications. So for example, with an open data set, that sounds great, but is it going to have representation of all of the different types of speakers that exist in the world, whether it's different voices from different people of all different shapes and sizes, or people with different accents or different languages? How are we going to make sure that that data set is representative? And if it isn't representative, how do we make sure that that doesn't skew the availability of technology for different people? On the side of the algorithms, like, sure, we can create algorithms that reduce data requirements, but can we do that in a way that doesn't also introduce bias, which is the tendency of an algorithm to produce results that lean in one direction more than another? And like, how do we measure that bias if it exists? And then on the synthetic data side, we have the same problem. Like, sure, we might think we can generate realistic data that can be used to train a model, but how do we really know that it is representative if we don't have a data set to compare it to? So all of these things are big challenges that people are working on solving, along with a lot of other challenges. It's important to remember we're in the very, very early days of machine learning and AI still, and a lot of this stuff, we have a lot of progress to make, but there's a lot of exciting work being done.
Yeah, where do you see this industry going in the next 5 to 10 years? And I guess from a privacy and security perspective, do you see this getting easier, or do you think this is actually going to get harder?
Yeah, it's interesting because I think in some ways, we're at the start of this amazing journey where we're going to see this technology become more widespread and used by more people and get into the hands of more domain experts. And that's what I care about the most, is how do we get tools that allow experts in subject matter areas to build using this technology without hitting some of the pitfalls that we're aware of as AI experts? How do I help someone who's an expert in wildlife train a model that works well to spot the type of wildlife they care about without falling into some of the traps that can allow you to think that you're, preserving privacy when you're not, or where you think your model is performing well or you're not? So I think that tooling is going to be really important, and we're going to see this technology become more widespread in use cases, in applications, as the tooling improves and becomes more widely used. The other part of this is that obviously as this scales, we're going to run into more situations where there are challenges from a responsibility perspective. A good example of that is with voice interfaces. So right now, only a small subset of people in the world use voice interfaces. As voice interfaces become more widespread, people who are maybe depending on a particular piece of technology are going to struggle if the voice interface doesn't support the way that they speak. And so as the technology becomes more widespread and scales, we'll start to run into problems that are direct results of whether we have represented the world's population adequately in our data sets. And so the problem gets more acute. When you're designing for a small subset of people, it's a lot easier because you can constrain your product. But when you're designing for everyone on the planet, things are a lot harder because you really have to have a fine grain of detail in your data set to capture all of the nuance that's out there in the world. So we've got to get better at understanding when we're meeting those goals, and also get better at delivering products that are high quality and help people's lives.
Yeah, I mean, bias in essentially training data is probably, its own deep dive topic on on its own, because that's also one of the big challenges. So there's a lot of challenges. It sounds like from a model training perspective, it's like, how do you get the data? How do you get the data in a way, if it's sensitive, that you're actually preserving privacy, you're doing it in an ethical manner, and then on top of that, how do you get the data in a way that's representative of essentially the population that you're trying to build this model and end user application for?
Yeah, absolutely. And one of the things that's sort of lingering there in the background, which is always good to think about to give a bit of context, is we talk about data in machine learning and in modern deep learning, and we have this assumption that we need these huge data sets. But if you take a little kid and you want to teach them a concept, you want to teach them what a word means or what the name is for something, it doesn't take 10 million samples of all sorts of people saying that word. They just have to hear it once or twice. And maybe they get tripped up by different accents, but it still doesn't take, this vast amount of data and this brute force approach, which inherently, is risky from a privacy and fairness point of view, in order for kids to learn words. So it's good to bear that in mind, that we have strong evidence that it's possible to do this much, much better than we're doing it right now. And so the goal of all of these researchers in this field is to get there. How can we get to the point where a automated system is as easy to train as a person? But even then, people are biased and people have these innate difficulties understanding certain things. So I think it's, there are some problems that are going to be very difficult to fully solve ever, but there's so much progress we can make from where we are now.
Yeah, I mean, that kind of goes to, I think, the point that some people in the machine learning field have made, coming from other areas as well, like, AI, traditional AI or pattern recognition, that, essentially a lot of what we've accomplished in the space over the last, 10 to 20 years has been getting better at essentially brute forcing these kind of, problems. Whereas, whatever is going on in the human mind is probably fundamentally different sort of model. We haven't really figured that out yet. And then of course that, could take us down the rabbit hole of, is a Turing machine, the same essentially computer that exists in our mind, or is that something that's fundamentally different? But we probably don't want to step on that landmine right now. It's going to take us in a whole other direction. But as we start to wrap up, I did want to mention you are a published author. You have a new book coming out as well. So what can you tell me a little bit about the book AI at the Edge?
Yeah, so thank you. I'm really excited about this book. My co-author, Jenny Plunkett, and I have been working on it over the last year. And it really is designed as an introduction to this entire topic of AI at the edge for pretty much anyone who is a technical thinker. So whether you're an engineer or whether you're a tech leader, or somebody who makes decisions around technology, or someone who manages products, or someone who's just interested in how this new piece of our industry works. It goes through everything from the beginning. So it talks through all of the embedded side, what are embedded devices? What are the different types? What are their different trade-offs? How can you design a system that makes sense in that world? And then it does the same with machine learning. So what are all the different types of machine learning and in fact, other algorithms that you can use to capture a little bit of human insight and deploy it to the edge? And it's really written, it's not like a programming book. It's a mostly prose guide that you can either use as a reference, or you can just go through and sort of build your mental framework for how all this stuff works. It's got a lot of best practices that we've identified from working with real customers at the heart of this industry. And it also has a few tutorial chapters that will take you through all of the steps needed to build a real project with real tools. So it's coming out in January, but it's already available on O'Reilly's online portals. So if you search for AI at the Edge O'Reilly, you'll find it. And I think you can sign up for a 7-day preview for free and read it if you're not a member of that already.
Awesome. Yeah. And we'll conclude a link to it definitely in the show notes. And Dan, as I said at the top of the show, it's always great to see you. We definitely need to catch up at some point outside of the context of a podcast interview. But thanks for so much for coming on. I think this is a really exciting area. Technology, innovation is still, like, as you said, very much in the early days. And I'm sure it's going to be have a massive expansion and a lot of innovation over the next 5 to 10 years and beyond. But best of luck to you and the rest of the Edge Impulse team.
Yeah, thank you so much. It's always such a pleasure to chat. And I really appreciate all the listeners who've tuned in to hear me rambling.
Thanks. All right. Cheers.
Bye-bye.